LC circuit oscillations is analogous to simple harmonic oscillations, the other name of free vibrations, where it corresponds to charge to displacement, current to velocity, inductance to mass, capacitance to reciprocal of force constant K, half mv square, which is kinetic energy, it will correspond to energy stored in inductor, that is magnetic energy half Li square, and potential energy being half Kx square will correspond to the electric energy stored in capacitor, that is half Q square by C. Analogous diagram of the LC oscillations with that of the one-dimensional harmonic oscillators. Equation of motions from the definitions of the simple harmonic oscillations, that is restoring force is proportional to negative of displacement, which will give us the equation of motion to be m d square x by dt square plus kx equal to 0. We can develop the equation of motion for these LC circuit in series combinations when it is in oscillations from two possible ways. One, we can start from conservation of energy principle, where we assume the total energy during the process of oscillation is only because of the electric energy and magnetic energy, which sum of these two energies is constant, and there is no loss of energy in the forms of Joule's energy, that is I square R, or there is no loss of radiation energy, that is electromagnetic energy, noise energy, there is no such noise we will assume in the form of sound, or air friction or damping losses. If no energy losses are there, then total energy being constant, then we can always write that is the total energy which is equal to half Li square plus half Q square by C, which is constant, because the sum of the electric energy and magnetic energy during the oscillation we say to be constant with respect to time. So therefore du by dt being 0, we can differentiate this total energy expression, that is half Li square plus half Q square by C, to be equal to 0. That will give us half twice Li di by dt plus half 2Q by C times dq by dt equal to 0, and that will give you L di by dt plus Q by C equal to 0. And using the current equal to dq by dt, we can get the equation of motion for LC oscillation to be equal to L d square Q by dt square plus d by C equal to 0. The other way how we can derive by using the Kirchhoff's voltage law, where we use the voltage drop across the inductor and capacitor to be equal to the total EMF. That we can write the voltage drop along the inductor L di by dt plus that of the capacitor Q by C equal to the EMF E. And during oscillation, since there is no source, so therefore the L di by dt plus Q by C has to be equal to 0. And using the concept I equal to d by dq by dt, we can write always L d square Q by dt square plus Q by C equal to 0, which is the equation of motion of LC oscillation. We can solve the equations as we have solved in case of simple harmonic oscillations, that d square x by dt square plus omega square x equal to 0, where omega is equal to square root of k by m, and here we will write d square q by dt square plus omega lc square q equal to 0, where omega subscript lc is equal to 1 upon square root of lc, which is the resonant frequency, we will say. The solution of these equations we can also get in a similar fashion with that of your inspection as we have done in case of the simple harmonic oscillations, where equation of motions for simple harmonic equation being d square x by dt square plus omega square x equal to 0, the solution will assume to be equal to x1 or of x2 forms, where x1 equal to a cos omega t type or x2 being b sin omega t types, and we will join for the general solutions to be x equal to x1 plus x2. That will give us the general solution of the form xt is equal to a sin omega t plus theta, or we can write it as xt equal to a cos omega t plus phi. And we can always replace by x equal to q and x1 equal to q1, x2 equal to q2 with small a equal to q0 to get the solution of equation of motion for LC oscillation. Square q by dt square plus omega square LC q equal to 0. We will get the solution qt equal to q0 cos omega t plus phi. That we can get. The other way, by complex method also, which leads to the idea of phasor, that is charge and current being function of time. So qt will assume of a to the power alpha t, and differentiating and substituting in the equation of motion for LC oscillations, we can get alpha square plus omega subscript LC square times a e to the power alpha t equal to 0. And our a e to the power alpha t being assumed solution cannot be 0. So therefore, what is 0 is alpha square plus omega LC square equal to 0. That will give us alpha is equal to plus or minus j times omega LC, where j is equal to square root of minus 1. With alpha 1 and alpha 2 are two possible roots, with alpha 1 equal to plus j omega LC and alpha 2 equal to minus j omega LC, and that will give us the total solution qt, which is equal to a1 e to the power alpha 1 t plus a2 e to the power alpha 2 t. So we can write alpha 1 and alpha 2, and the equation will become qt equal to a1 e to the power plus j omega LC t plus a2 e to the power minus j omega LC t. Now as you know, all the charges sitting with capacitor C at time t equal to 0 in our figure. So therefore current is also 0 at time t equal to 0. So we can write Q at time t equal to 0, which is equal to the maximum charges Q0. We can take it, that will be equal to a1 e to the power 0 plus a2 e to the power 0, which is equal to a1 plus a2. And for time t equal to 0, dq by dt, which is equal to I, that is also being equal to 0, which will give, in substituting the equation, that is j omega LC a1 e to the power 0 minus j omega LC a2 e to the power 0, and that will give us j omega LC times a1 minus a2. Now we can solve always these two equations for q0 and I equal to 0 to get the values of a1 a2 equal to q0 by 2. So therefore the solution of the equations we can get, that is qt equal to q0 by 2 e to the power j omega LC t plus e to the power minus j omega LC t. And as we know, cos function can be written in an exponential form. So therefore we can always write e to the power j omega LC t plus e to the power minus j omega LC t by 2 to be equal to cos omega LC t. So therefore the solution becomes qt, which is equal to q0 cos omega LC t, and that can be written as q0 sin omega LC t plus pi by 2. The graphical comparisons, we can see the charge versus time and current versus time graph and compare with the displacement time and velocity time graph in both the cases, where we find that wherever charge is maximum, current is minimum, and vice versa. In the same case, where your velocity is minimum, your displacement is maximum. Now our comparisons with that of your charge with a displacement and current with velocity is comparable in a graphical manner also. And in the same way, we can compare the kinetic energy, potential energy with that of the magnetic energy and electric energy, which we have written as UB is equal to half Li square and UE is equal to half Q square by C. In a graphical form, we can compare. But nevertheless, in both the cases, the total energy remains the same. Pictorial forms of the one-dimensional harmonic oscillator with that of the LC oscillation. Now the 8 figures which we have shown, we can start with the figure A, where that here all the charges in the capacitors is sitting and there is no current flowing in these circuits. We have given 6 lines here and arrows are downward, in the sense that we assume the positive charges are on the top of the capacitor plates. Recalling to the concept that whenever these frequency dependent electrical parameters like L and C are connected, the process is non-instantaneous, unlike the case of a resistor where you switch on and get the light immediately. The next figure B, if you focus, some positive charges have been transferred to the inductors. We have shown 3 lines here. So half of the charges has been transferred from the capacitor to the inductors, and thereby the energy in the inductors is piled up and the energy is half here we have shown. In figure C, all the charges in the capacitors has been vacated. All the positive charges in the top floors has been now vacated, and the entire energy of the capacitor energy, which is equal to half Q square by C, is now with that of the inductor being the maximum energy, half Li square, all being the magnetic forms. So we have shown the
8 lines of force.
When all the charges have been transferred to the capacitors, so since no charges are there in the plates of the capacitor, the electric field is 0. So therefore the current is now going to be 0. So recalling the property of inductors, it always opposes any change in the flux. So whenever there is a change in flux from maximum electric field, in a subsequent manner gradually it comes to 0. This inductor revives the current by supplying a back EMF. And if you see, as if all these hitting charges, now the inductor tries to supply to the bottom of the parallel plate capacitors. So the charges now starts flowing to the bottom of the parallel plate capacitors, and when this process is going on, we always have to remember that the process we are discussing is non-instantaneous. Figure D, if you see, the capacitors have accumulated half of the positive charges in the bottom, and this process goes till all the positive charges are now gathered in the bottom plate of the parallel plate capacitors, and by that times all the charges from the inductor has been transferred to the capacitors, that the magnetic energy has become zero in the inductors, and finally the entire energy is with that of your capacitors. Only difference between figure A and E is that there is a reversal of polarity of the plate of the capacitors. And this process we can compare with the one-dimensional harmonic oscillator with the starting of that of your figure A, where your displacement is maximum and velocity is zero, and in the case where the energy, kinetic energy is maximum, that is velocity is maximum, in that case your total energy is with that of your inductors. And in the same way you can compare with that of your figure E, where all the energy with that of your capacitors is in the form of potential energy. So therefore the V being velocity being zero, so therefore the kinetic energy with the one-dimensional harmonic oscillator is zero. And in each of these two cases, figure A and figure E, the body under oscillation is temporarily at rest, and this process continuously go in a anti-clockwise in a circular manner as we have shown in the diagrams. This is actually how the oscillation process goes, and continuously magnetic energy is transferred to the electric energy to the capacitors, and the charges are continuously coming to the bottom plates and going to top plates, and charges are always piling up with the inductors, and again it is piling up with that of the capacitors. It is not a instantaneous process. When you see the oscillations of LC circuit, such kind of current during oscillation is called worthless current or idle current, and LC circuit, if connected in parallel to the transistor input, of course under positive feedback condition, then it behaves as a oscillators. And when it is connected in bisection manner with the AC output, it behaves also as a filter circuit. So AC circuit has versatile applications. We will see more about the LC circuits in our subsequent discussion during electronics. Thank you.